Okay, let's first start creating our little model. So let's just create a tube. Let's do end caps. Let's just quickly model the whole thing. So polygon, I guess. Let's do let's put this thing to polygon to modeling. I never really model inside of Houdini, so I'm super slow with this whole process. Polygons, poly extrude, then inset. Let's repeat the process, something like that. Then let's inset, something like that, and then maybe polybubble. Let's group some edges. And again, I know I'm doing a little bit faster now, but if you want to reiterate how stuff like this works, just go back into the earlier parts that show how this stuff works and refer back to those. So I'm just grouping here based on edge angle, so group 1, and then I'm gonna bevel those edges. All right. So I guess that's an okay knob. Maybe it will be cool to also do some like more of an inset here as well. So maybe 2 divisions. Maybe if we subdivide, I think this whole thing. Yeah, it might look a little bit better. All right, let's use this as a knob. We don't really need to subdivide it right now because we can do render time subdivision. Well, let's put down a knob and call it out knob. And that's what you generally do a lot of times, is just put down a null and name it something. You can also color code it if you want to be easy to find it. So with C, you open the color panel, because this way you can sort of, it's just easy to refer back to certain objects. So this will be our knob. What you could even do is say, this is our model. I could even click this create subnet, which is also Shift C, which would create a subnet. And so if I dive inside here, you can see this is our model. So right now it's just contained within one node. So you can sort of organize your node tree like that as well. Right, so let's start placing these things on top of our curves. Let's maybe close this thing down a little bit for now. All right, so okay, so there's a couple of things we need to do. So you might think, let's scatter on this. So on the point, on the thing. But you can see we get a super inconsistent thing here. And when we play, so if we play, you can see they're sort of jumping around. So that's not really ideal. So kind of what we want to do first is put down a time shift. So what time shift will do is shift time. Kind of makes sense, right? So by default, this is just set to $F, which means means the current frame. So frame 108 here, frame 108. So what I can do is if I delete this channel, so right click delete channel, now it allows me to put in a frame. So if I scrub through this, you can see it will sort of put in a certain frame. So let's just put it to frame 1. So this will be sort of a rest position. So we can do stuff on this without it animating. So if I scatter on this now, you see that I have points on here. And of course, now they won't randomly move about. So that's already a lot better. Okay, but you kind of want these to sort of move with the original curve. Because, I mean, we do want to keep the animation, right? So there's multiple ways to do that. But let's make just let's just do a simple node called point deform. So point deform will allow you to give a geometry that you want to deform, so mesh to deform, first input. Then rest point lattice. So this means what do we want to use as a rest geometry? So that's of course the thing we use the time shift. And then deformed point lattice. So what do we want to use to deform? Let's just use the animated thing. Let's have a look. Now you can see it's animating, but we don't have the jittering stuff going on. So far so good, right? But you might notice that sort of the distribution along these things is super, well, not great. So if I make it like a lot lower, like some curves will have, like if I template my curves, some curves will have only 1 or 2, and some will have a lot. So it's not really ideal. So how can we solve this? So we're going to use something called a for each loop. So that's something we haven't used before, which is super useful, and you use it a lot. So if you go also on my website, in conjunction to all of the stuff that we made in this tutorial, I have more stuff on there as well, included in the source files. For example, there's this this bridge thing, which like sort of procedural bridge, which you can sort of control. So that will also use a lot of the things that we've been sort of discussing. So yeah, you can have why is that not working? Oh, sorry, that needs to be 0.5. So you have like a lot of these controls, panels, length. So and that uses a lot of the same things, including the for each loops and stuff. So I mean, do check that out. You can download that if you're a Patreon supporter. So that will all be on my website, and there will be like exclusive little tutorials breaking this stuff down as well. So anyway, so that's for Patreon supporters only. You get access to a Patreon only part of the course. So anyway, so let's continue a little bit. So we have these points, and let's make a for each. So okay, so if you type for each, you can see there's a whole bunch of different different types of for each loops. It's actually the same thing, but it's just a different preset. So if I type for each connected thing, what it does is it drops down a connectivity. So connectivity will create an attribute called class, and it can do it either for every point or for every primitive. Well, it will put it on points or on primitives. So that's a better way to put it, because if I put it on points, it will still do it for every connected thing, but it will just put it on the points. So anyway, so if I put it on every primitive, you can see I get, for every line, I get an attribute called class. And then the for each loop is set to be run over the class attribute. So what it will do is inside this loop, I get access to each individual element. So if I highlight the top one, you can see I get access to one of the things. So this one has class 24. I can also put this thing to, so if I go down here to put it to a single pass, and it will only, it will only iterate on one of the things. But what this will do is that anything I put inside here will run for each of these individual elements. So if I grab this scatter and then put it in here, I now can scatter points for just this primitive. So I can say, maybe how many do I want? Maybe I want 10. And maybe I want to increase the relax iteration, so it's sort of more uniform. Because again, you can sort of relax the thing. So it will just evenly space them out, sort of smooth that scatter thing. So if I then go to the end of the loop, you can see now I got super even distribution, because I'm doing now the scatter instead of just scattering randomly across these things. Now it will treat every line individually and scatter points on it. It will scatter 10 points per line. I can make it less, I could make it 8 or whatever. And it will relax the shit out of it. And then it will sort of do it for everything. And then if I plug this into the pointer form over here, and now let's check the animated thing. So let's template our curves maybe. So now you can see we kind of need to tweak maybe our pointer form, because you can see it's sort of moving off the thing sometimes. So what this is basically doing is sort of looking around every point, and then sort of like saying how many points should I look around for, and then sort of taking an average and then deforming that. So maybe what we need to do is turn down the maximum points. Let's see what this does. So now you can see with the maximum points turned down, they sort of stick nicely to it. So maybe I do want it to be a little bit more randomly sampled. So this sort of roughly gives us what we want. Some will slide a little bit, but for this procedural setup, that's sort of, I mean, you're not gonna see that. If you wanted to sort of not have because these curves sometimes also get longer and shorter because we are adding to the position. That's just a thing that you are gonna get when you're doing this like procedurally driven like this. If you're doing this with simulation, of course you could like do that differently, but again, this course is not about simulation. So yeah, now we have a nicely we have the curves looping, and then we have these things, and now let's start putting some copying the knobs on it. Right, so let's just copy some stuff to it. Let's make it packed in this case, because it just will be faster. Because again, if you use packed, then it will be references to the original geo. So right now, as you can see, I can sort of select those. Why is it acting weird? Okay, wait. So let's go to the first frame. So now we can you can select these things as points individually. And like if we were to not pack them, then you can see it's just geometry. So, okay, so now we have these things, but you can see the sort of the way they angle looks a little bit weird, right? Because they are being oriented into the normal direction. So if you remember, we used the polyframe to angle them in a specific direction. Oh, and by the way, you can see there's this weird thing now going on where we keep seeing our points. So that's a viewport bug that's been in Houdini since forever. How you can get rid of the viewport bug is either closing Houdini and opening it again, or you can just close your view. So scene view there, close it, press the plus icon, go to new view tab, viewers, scene view. Now you can see the problem is gone. So quick tip. Right, so if we merge these things together with the thing, by the way, let's maybe merge it over here so we just look at these things. So they're located inside of the tentacles, which we don't want. What we want is to sort of push them inside. So now you might think, like, how can we do it?